Indian Space Research Organization, ISRO, scripted history as Chandrayaan-3 spacecraft made a soft landing on the surface of the Moon Wednesday evening. The Vikram lander made the soft landing at 6:04 p.m. IST. With the mission's success, India has become the first country to land a spacecraft near the lunar South Pole. In fact, India is only the fourth country in history to complete a soft landing on the Moon after the United States, the Soviet Union and China. Chandrayaan-3 Launch Vehicle Integration. Chandrayaan-3 Launch Vehicle Integration. The Chandrayaan-3 lander, with its rover inside, sits atop the propulsion module that will carry it to lunar orbit. The rocket's protective aeroshell fairings, which protect the spacecraft during launch and ascent, can be seen in the background. Image, ISRO. The Chandrayaan-3 lander and rover are similar in design to those from the Chandrayaan-2 mission. In September 2019, the Chandrayaan-2 Vikram lander successfully lowered itself to within 5 kilometers, 3 miles, of the Moon, entering a fine braking mode that would have placed it gently on the lunar surface. Like its successor, Chandrayaan-2 was targeting the Moon's south polar region, where ice has been found inside permanently shadowed craters. Unfortunately, a software glitch caused Vikram to veer off course, and ISRO officials lost contact with the spacecraft. NASA's Lunar Reconnaissance Orbiter later found debris from the vehicle scattered about 750 meters, a half mile, from the intended landing area. The mission was not a total loss. Chandrayaan-2 also included an orbiter that continues to study the Moon from above. Among other scientific functions, the orbiter is equipped to scan for water ice. Having figured out what doomed the Vikram lander, ISRO says they have upgraded the lander software and performed numerous tests to ensure that Chandrayaan-3 goes according to plan. Chandrayaan-3 does not include an orbiter, although the propulsion module that will carry the lander to lunar orbit is equipped with a science instrument that will observe Earth as if it were an exoplanet, providing data for future exoplanet studies.
How did Chandrayaan-3 get to the lunar surface?
From liftoff to touchdown, it took about 40 days to place Chandrayaan-3 on the lunar surface. The mission began on July 14, 2023 with a launch aboard India's LVM-3 rocket, the country's heavy lift vehicle capable of placing about 8 metric tons into low Earth orbit. For comparison, the SpaceX Falcon 9 rocket can lift almost 23 metric tons to low Earth orbit. The LVM-3 placed the spacecraft and an attached propulsion module into an elongated Earth orbit with an apogee, or high point, of about 36,500 kilometers, 22,700 miles, above the planet. The propulsion module raised its orbit several times before transferring into lunar orbit. At the Moon, the propulsion module lowered Chandrayaan-3 until it reached a circular, 100-kilometer, 62-mile, orbit. There, the two vehicles separated, leaving the lander to deorbit and touch down in the Moon's south polar region. At the moment of contact, the lander was expected to move less than 2 meters per second vertically, and 0.5 meters per second horizontally, 6.5 and 1.6 feet per second, respectively.
What will Chandrayaan-3 do on the Moon?
A successful touchdown marked a huge achievement for ISRO, placing them in a small group of nations that have landed spacecraft on other worlds. Beyond this milestone, Chandrayaan-3 has technologies to demonstrate in science to perform. Shortly after landing, one side panel of the Chandrayaan-3 lander will unfold, creating a ramp for the rover. The rover will emerge from the lander's belly, drive down the ramp, and begin exploring the lunar environment. The solar-powered lander and rover will have about 2 weeks to study their surroundings. They are not designed to survive the chilly lunar night. The rover can only communicate with the lander, which communicates directly with Earth. ISRO says the Chandrayaan-2 orbiter can also be used as a contingency communications relay. The rover has 2 payloads. Laser-induced breakdown spectroscope, LIBS determines the chemical and mineralogical composition of the surface. Alpha particle X-ray spectrometer, APXS, determines the elemental composition of the surface. ISRO specifically mentions magnesium, aluminum, silicon, potassium, calcium, titanium, and iron as elements the rover will hunt. The lander has 4 payloads. Radio anatomy of moon bound hypersensitive ionosphere and atmosphere. Brahma measures how the local gas and plasma environment changes over time. Chandra's surface thermophysical experiment. CHASE studies the surface's thermal properties. Instrument for lunar seismic activity. ILSA measures seismic activity at the landing site in order to delineate